to one more session of your hydrocarbons. So till now what did we learn? We have learned the different hydrocarbons, that is alkenes, alkenes and alkynes. Then I took you into a concept of aromatic hydrocarbons, that is arenes. In aromatic hydrocarbons, I have also taught in the previous video nomenclature of arene compounds, isn't it? I've shown you different examples, almost 40 plus examples I have taken. In that I picked up examples, then I started teaching you the different the naming or nomenclature, the IUPAC nomenclature, everything I've taught in the previous video. Please watch the video and come back to this topic. Now today, the topic which we are going to learn is structure of benzene, right? So when I speak about structure of benzene, first of all, what is the formula of benzene? Benzene formula is C6H6, isn't it? Right. To name, or what is this for? This is a molecular formula. So we are going to write molecular formula of benzene. When somebody asks you what is the molecular formula, this is the formula. Now to explain the structure of benzene, isn't it? They have, the different hypotheses, different statements were given for the structure. Let's see what are the different hypotheses of the structures and what are the valid. What is the valid explanation given here to explain the structure of benzene? First, Huckel was a person who was given the structure of benzene. Apart from that, we'll be studying Huckel structures. Apart from that, several other structures also were given, but they were not accepted. For example, we listen Dewar structure. Dewar structure of benzene also was given. Okay, Huckel structure, Dewar structure. After Dewar structure, it was Claus structure. After this, it was Armstrong structure. Okay, these are the different types where they were not accepted only, but we're going to see all those. Then Ladenburg structure. After that came into existence Levine and Cole structure. Then came into existence the modern view, where it is there in your NCERT also. So in this modern view of benzene, we are going to study the structure of benzene based on resonance concept. After that, I'll be teaching you the orbital structure, where we call it as orbital structure. In that orbital structure, means this only the same thing, I'll be teaching under orbital structure. So after orbital structure, basically, I'll be showing you which is hybridized, what is hybridization of that, everything. In this only, I'll be teaching you a concept called Huckel's rule. Huckel's rule. Right? So these are the different structures. So let us start. Among these, Huckel structure was the accepted one. There were few objections, but Huckel structure is the accepted one. Next comes resonance is an accepted one. Orbital structure is an accepted one. And Huckel's rule, the most important, is accepted. So all these were not accepted because of certain objections, which we will see. So not accepted. Done. We have written this, and let's see one after the other. So when I have to speak about the Huckel structure of benzene, basically, so first important thing you remember is, whenever you take benzene, right, what are the important things which you should remember? See, and then we will go to the structure. So whenever we see, first important, okay, you should remember the points to remember in benzene. So remember, I'm writing this, points to remember. Remember for benzene. Okay, for benzene, what are the important points you have to remember for benzene? Remember, just see, note it. So for benzene, I said it has alternate double bond, isn't it? In the whole structure of benzene, there are 3 bonds which are arranged alternatively. So if I have to find its degree of unsaturation, right? Alkenes also have, alkynes also have double bond and triple bond. If I have to calculate degree of unsaturation, so what is this? I have to write 2 into 6 plus 2 by 2 minus 6. Okay, so when I'm calculating the degree of unsaturation, how much do I get? I'm getting 4. Now what is this? Is the formula for this? So directly written the values here. So when I get 4. So when compared to alkenes and alkynes, the unsaturation is very high, isn't it? It is 4. That's so we should write unsaturation is high in benzene compared to what? Benzene compared to alkenes and alkynes. Okay, so this is one thing which you should remember. First important, so unsaturation is high. Second thing, important concept which you should remember is, whenever I speak about unsaturation, what do we think about? Our first concept comes to bromine water test, isn't it? Right? So important thing is, it does not decolorize bromine water. Okay, so remember, because we do test for unsaturation, isn't it, using bromine water. So it does not decolorize, benzene does not decolorize bromine water. That's important thing. Next, it also does not decolorize Bayes test. Means these are all general Bayes reagent. All these are general things which you should remember. These are common. These are important. What do you say? These explain the basic importance. Means benzene will not respond to this. Benzene will not respond. This is what you have to take out as a criteria while studying benzene. So it does not decolorize. When you add bromine water, it will not decolorize. It will not even decolorize Bayes reagent. Next important thing is, it is not oxidized by, third thing, not oxidized by, what are the oxidizing agent? KMnO4, isn't it? It is not oxidized by, this is it, by alkaline KMnO4. We will see the reason also one after the other. First let us note everything. KMnO4, or one more reagent, acidified potassium dichromate, E2Cr2O7. This is one more characteristic of benzene. Next important thing which you should remember, let us write here only. Next important thing, instead of undergoing, because we said it has high unsaturation in it, isn't it? But here, instead of undergoing addition reactions, we'll try to prefer undergoing substitution reactions only. Right, remember that. So what I'm going to write here, instead of, why also we're going to see the reason very soon. Instead of undergoing addition reactions, it undergoes substitution reactions. So note all these points. So any question will be asked from any part of the point given. Undergoes substitution reactions. That. Next important thing, we said it will not decolorize bromine water, it will not decolorize Bayes reagent, not oxidized by oxidizing agents like potassium dichromate and potassium permanganate, right? So next we have written it undergo only substitution reactions, not addition reactions. That's also fine. Now, next important thing, whenever I take benzene, okay, suppose if I take benzene, this is C6H6. Now I'm going to hydrogenate. Hydrogenate means addition of hydrogen, and that too this occurs in the presence of, because whenever you're adding hydrogen, that is a reduction, you require reducing agent like metal. So nickel, the temperature which I'm going to use is 180 degrees. So here I'm going to add 3 moles of this. Then what happens? This gets converted. 3 to the 6, no? 6 hydrogens you are adding. So these 6 hydrogens will add to this. This becomes 6 plus 6, 12. So C6H12. What is this compound now? This is called cyclohexane. What is this compound? This is benzene, isn't it? Right? So whenever you're doing hydrogenation reaction to benzene, benzene gets converted to cyclohexane. Remember that. Now, suppose if you're trying to take the same benzene, I'm taking the same benzene. Now I'm allowing it to undergo chlorination. This is hydrogenation, this is chlorination. Hydrogenation is nothing but addition of hydrogen. Chlorination is nothing but addition of chlorine. Again, I'm going to take 3 moles of this, but this occurs in the presence of sunlight. This is very, very important. So in the presence of sunlight, what happens? Benzene combines with 3 moles of chlorine. And what does it form? It forms a compound. Now let us count how many are there. 3 to the 6. You're going to add these 6 to benzene. This is going to form a compound C6H6 and Cl6. 6 are there directly. So what is the name of the compound? This is called BHC. Let's see what is the name of this. B stands for benzene, H stands for hexa, C stands for chloride. Let us write what we have written. It is benzene hexachloride. So if you had 3 to the 6 hydrogens, 3 to the 6 chlorines got added to this. So these two reactions, what do they confirm? These two perfectly confirm that the presence of 3 pi bonds. If our teachers asked you what are the 2 reactions which confirm the presence of 3 pi bonds, just write hydrogenation and chlorination reactions of benzene. Please, you can note this out. Benzene confirms the presence of 3 pi bonds. How did I do 3 pi bonds? How did I get this? See here, because of the presence of 3 pi bonds, those 3 pi bonds broke and 6 hydrogens added. Here also, the presence of 3 pi bonds, those broke and 6 chlorines got added. So these two reactions are very important to confirm the presence of pi bond. And next important thing, whenever you're taking benzene, you have to also remember which point is that. I've written 6th point. Let me write the 7th point. So where this, before Kecool also came into existence, several structures were given, means several open chain structures were also assigned to explain the benzene structure. What was it? Several open chain structures, like, let us see, several open chain structures. So now we've come to a conclusion that it's a cyclic structure, but before that several open chain structures were introduced. Like we said C6H6, isn't it? So that C6H6 was divided into, it was shown like this: 1 double bond C, this is triple C, okay, H later we can write, double and C. This was also given. Now fill in the hydrogens. H2, this is H, there is no hydrogen here, this is H and this is CH2. This was, such structure was given, which is not accepted only. One more structure which they gave was this also was one more structure which was given to benzene. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 carbons. This was also not accepted, right? There is one more structure which was given in this way. There is one more CH2. This is also linked to CH2. These 3 are linked, and now there is a double bond. They've given double bond here. So such structures were given to benzene which was not accepted. Then after all these conditions and after everything, benzene structure, a proper and acceptable structure was given by Kecool. So let us come back and do the Kecool structure of benzene. Thank you for watching, students. Welcome back, students. So in the previous video I've taught you the different, means what are the characteristics, how do you assign the properties to benzene, whether it will decolorize bromine water, whether it gets oxidized with potassium permanganate dichromate, or is it going to undergo hydrogenation reactions or chlorination reactions. Now in this video we'll be studying about the structure of benzene, that is the valid structure, that is Kecool structure of benzene. So some say it is Kecool, right? So I'm using the word Kecool structure of benzene. So basically, what did Kecool explain us? So Kecool, most important thing is he's proposed a ring structure. Okay, Kecool has proposed a ring. So we call this ring as cyclic structure. So cyclic structure of benzene, this is what Kecool has proposed. Now according to him, what is that? He said benzene has a planar hexagonal structure. The first important point, or first important concept which he has explained is benzene has. So we are going to start like this. What does it have? Benzene has a planar. Okay, we will see what it is. A single plane, like just one sheet like this, not a 3-dimensional structure. A planar hexagonal. Okay, there are structure. So in this planar hexagonal structure, what does it have? This planar hexagonal structure has 6 carbon atoms. First important thing, right? So 6 carbon atoms, where are they present? They are present at the corners. After that, each carbon atom, there are 6 carbon atoms, isn't it? Again, this 6 carbon atom is attached to hydrogen. So you have 6 carbon atoms with 6 hydrogen atoms. Okay, attached to carbons only in the corners. This is also over. Now, to satisfy the fourth valency, what will happen? He further said, along with this, he also said there is alternate pi bond. So, what is the alternate pi bond? And this is he said there are alternate pi bonds in the ring. So this became as a familiar structure with this concept. 6 carbon atoms at the corner, 6 hydrogen atoms at the corner attached to carbon, and the fourth valency is satisfied by alternate pi bonds. So how is the Huckel structure? The basic thing which we draw every time. So 6 carbon atoms, isn't it? 1, okay, 2, 3, 4, 5, 6. So all the corners now join 1, 2, 3, 4, 5, 6. 6 corners, 6 carbon atoms, 6 hydrogen. I said alternate. This is over. This is over. Now alternate pi bonds. Alternate pi bonds here. Leave one. Second, leave this. And this is your Huckel structure. So what is this? This the ring, whatever is here, it is symmetrical, isn't it, with its structure? So this, let us say, this is symmetrical. Symmetrical. So this is a Huckel structure. Now it confirms uniformity because of the structure, Huckel structure. It confirms the formation of very important concept. Just see, what does it say? It confirms structure. Does right? Structure. Its structure, Huckel structure. So Huckel structure confirms the formation of. So because of this, we are going to learn first important thing. Only one mono-substituted product. What does that mean? That means C6H6 is a formula. Now C6H5Z. What is this? This is a mono-substituted compound. Means one hydrogen is replaced. So only one mono-substitution product, C6H5Z, irrespective of which hydrogen it is displaced, it forms. Whichever hydrogen. In the 6 carbons, whichever it is displaced, it's going to show mono-substituted product. Now, suppose if I take the second one. So, what is this one? This is only one mono-substitution product. Now, what is the next one? Mono-substituted product irrespective of which hydrogen among the 6, which hydrogen it is going to replace, that is irrespective of which hydrogen is displaced. This is one concept because of the Huckel structure. Next, suppose we take 3 distribution products. How? Means mono, I said, suppose if you are going to get 3, you will be also getting 3 products. How? At 1, 2 means, let's see, if I take benzene like this is 1, 2, 3, 4, 5, 6. That means you may get di substitution products, right? So it can be here 1 and 2. Okay, it's 2. 1 and 3 is 2. 1 and 4. So what are this? When they form like that, then we call it as ortho. This is meta, and this is para distribution. So ortho, meta, para, di substituted products. This is mono substituted product. This is di substituted product. Done. So it is found that it produces, means this also and this also. It's going to form this and this. But what did he say? That means further when you study, you'll be seeing products formed at ortho and para also, meta also. That's why this is a combination 1, 2, 1, 3 and 1, 4. Now there were certain objections to Huckel structure. Very few objections were there. Huckel structure, what are these? We'll see. So we will learn under some objections. Why was Huckel structure objective? We'll see some objections to Huckel structure. Some objections. So first thing, see here, we said 1, 2, 1, 3, 1, 4 combinations, isn't it? Now it has to form 2 different types of ortho disubstitution products with this structure, isn't it? Right? So whoever has objected Kekul's structure, they said according to the structure it has to form two different ortho substituted product. Substituted or substitution product. How should it look? It should look like this. This is one benzene ring. Okay. One compound, one element is here, X, and one more Y. This is ortho position. And one more, it should also form one Y here and X here. So it has to form two different ortho disubstituted product with this structure. Right? Is it forming? No, isn't it? So this is what they objected, and it also failed to explain. It could not explain why why benzene does not undergo oxidation with KMnO4. So it failed to explain. Kekul's structure failed to explain the reason why benzene does not, we told initially, isn't it? It does not undergo, or it will not undergo oxidation with KMnO4 or with potassium dichromate. He could not explain the reason why benzene does not undergo we told oxidation. Basically oxidative degradation means why does it not undergo oxidation with oxidizing agent, isn't it? Oxidative degradation with alkaline KMnO4. Okay, alkaline KMnO4. Then so this also was not explained by Kekul, the main reason. So here in this was one objection and this was one objection. What was the objection in the above case? According to Kekul, he said the pi bonds are static. Pi bonds are static, he said. He did not say according to orbital diagram it will get delocalized. Because pi bonds are static, this concept will not work, isn't it? That's why Kekul's structure was questioned for that. Right. So now several other structures came into existence. Now we'll be seeing the several other structures for Kekul. So whenever you're drawing the Kekul structure, either you can make it in this way. How did I make? You can write it as cyclic ring structure 1, 2, 3, 4, 5, 6, isn't it? All joined together with carbons, as he has shown. Carbon, and this is linked with hydrogen. 6 corners. Hydrogen are there, and along with that you have alternate pi bonds. If I start with the first one, this is, if we take one pi bond here, leave one, second one, leave one, and third. The same thing you can denote in this way. This is your Kekul structure of benzene. This is benzene. Which one? This is your Kekul structure. So this is your answer. Thank you for watching, students. I'll meet you again with the next type of structures of benzene.